we have already seen in the previous lecture that when a charged particle moving at right angles to the magnetic field, charged particle moving with velocity, moving at right angles with a magnetic field. Suppose this is the magnetic field. The magnetic field is into the plane of the paper, into the plane of the paper, and the particle is moving like this. See, particle is moving because the linear velocity will be a tangent. Here also that linear velocity will be like this. Linear velocity at this point. This is linear velocity of the charge. The charge is moving like this. Here also, in this along this, draw the tangent that gives the linear velocity of the particle. By using Fleming's left hand rule, the magnetic field is into the plane of the paper. See, magnetic field is into the plane of the paper, and the velocity is downwards. This gives a direction of magnetic force, Fm. Similarly, here also, this is the magnetic force. This is the magnetic force. Same way here also, this way, magnetic force. So, it means the magnetic force moving at right angles to the magnetic field, it moves in circular path. It moves in the circular path. To move a particle to move in a circular path, there has supposed to be a centripetal force. This centripetal force. The centripetal force is provided by magnetic force. Magnetic force Fm. That is, centripetal is mass of the particle, velocity mv square by r. This is the centripetal force, which is equal to q into v into b into sine theta. What is theta? Theta is the angle between velocity and magnetic field. Velocity and both are perpendicular. It means theta is equal to 90 degree, and sine 90, that is m v square by r is equal to q into v into b. Sine 90 is 1. So with this we can calculate what we have to calculate the radius of the magnetic field, radius of this circular path, where this is r, radius of the circular path. R is equal to, from this expression, r is equal to mv by qb, and velocity is equal to r bq by m, and r is equal to this much. Now we can, from this, what is the radius? Radius can be written, this radius, see, p is equal to momentum of the particle, which is equal to mass into its velocity. So this m and v can be written as p, because this is equal to p divided by q into b. Therefore, p is equal to q into b. This where p stands for the momentum. Momentum is equal to mass into velocity, momentum of the charged particle. So when a charged particle, now you see here, when a charged particle is accelerated through a potential difference of v, then it gains speed. It means it gains kinetic energy. When a charged particle, that is q, accelerated by a potential difference, accelerated by a potential difference. Potential difference means here it is higher potential, the charge will move like this, it will be accelerated and it will gain kinetic energy. Potential difference V, it acquires kinetic energy. It acquires kinetic energy. So it is acquires kinetic energies. It is acquires kinetic energy, or in simple we say Ki. It acquires kinetic energy. Therefore, kinetic energy is equal to half into mass into velocity square, which is equal to charge into potential difference. Because when a charge particle is applied across a potential difference, it is accelerated, gains kinetic energy, which is equal to half into mv square. Or we can write half mv square, we can write half into m square v square by m is equal to q into v. So mv, where mv is equal to p, and m square v square is equal to p square. That is half into p square, m square v square. This will become p square by m is equal to kinetic energy, because q into v is equal to kinetic energy, or we can say K. Q into v is equal to kinetic energy, or p square, that is p square is equal to 2m into k, where k is equal to kinetic energy. K is equal to kinetic energy of the particle, or p is equal to under root 2m into k. So this is the expression for the momentum of a particle, or we can say what is radius. So from this expression, the radius is equal to p divided by qb. So p, in place of p we can substitute under root 2m into k divided by q into b, as it is k. K also can be written as under root 2m, since k is equal to qv. K into q into velocity, where qv is equal to velocity divided by q. That is the expression for r. Therefore, r can be found out by using this equation. R is equal to p by qb, and r is equal to under root 2mk divided by qb. R is equal to qvm divided by qb. And what about the kinetic energy, expression for the kinetic energy? So kinetic energy can be written as half mv square. So kinetic energy is equal to, of the particle, is equal to m into v square. So kinetic energy, what is v? Half into m into v square, that is r b q divided by m and its square, because v expression is this one, is equal to half into r square b square q square divided by m. This is the expression for kinetic energy of a particle moving in a magnetic field at right angles. So the kinetic energy can be given with this expression, half into r square b square q square divided by m, where r stands for the radius of the orbit, rad bit as a circular orbit, and b stands for the magnetic field, q is the charge, m is the mass of the charge.